Hello everyone. In previous video session, we have seen how we can find the hardness of water by EDTA method, the theoretical explanation for it. So in that video session's description, also I have shared a link for how practically that experiment is performed in laboratory. So you can check it. And in this session, we are going to solve a numerical for finding hardness of water by EDTA method. So let's begin. So here it is given that 100 ml of water requires 18.5 ml M by 50 disodium EDTA for endpoint in titration. Then it is given 100 ml of the same water sample after boiling and filtration takes 10.7 ml of the disodium EDTA for endpoint in titration. We have to calculate temporary and permanent hardness of water sample in ppm of CaCO3 equivalent, in ppm of calcium carbonate equivalent. So first let's take down what is given. So first statement, it is given that the quantity of water sample, volume of water sample, which we are assuming it as V, is 100 ml. Okay, and for that water sample we required EDTA, that is 18.5 ml. So we have taken V1. We required 18.5 ml of EDTA. Now it is also given, if you looked at the question, it is given 18.5 ml of M by 50 EDTA. So M by 50 is actually the concentration of EDTA, which is in molarities, that is capital M. So M by 50 means 1 by 50 because M is actually the unit for molarity. So 1 by 50 means the concentration of EDTA is 0.02 molar. So these details are given in the first line. In second line, it is given that 100 ml of the same water sample after boiling and filtration. So again we took 100 ml of water sample, same water sample, but it was first boiled and filtered. So 100 ml of same water sample after boiling and filtration required 10.7 ml of EDTA for endpoint. So given is, now this time the volume of water sample is again 100. ml of EDTA required is 10.7. We have taken it as V2 because after boiling and filtration we require 10.7. So now we have used the same EDTA solution. So the concentration of EDTA would be same, which is 0.02 molar. And now we have to calculate temporary and permanent hardness of water. So to calculate temporary and permanent hardness of water, we need to remember what is temporary hardness and what is permanent hardness. So temporary hardness, which is also called as carbonate hardness, and permanent is non-carbonate hardness. So the basic difference between these two is that the temporary hardness in water can be easily removed by boiling, while permanent hardness, as the name suggests, it cannot be easily removed by boiling. It requires special chemical treatment. So the difference is, now when you look at the first line, we have just taken a water sample, treated it with disodium salt of EDTA till we get the end point. That is from wine red to blue, the color should change. So when we take the first statement, the first given things which are given, and put it in the formula, the hardness which we are going to get, it is going to be a total hardness because it is an untreated water sample. So first would be total hardness because we have just taken a water sample which is untreated. So the formula is V1 into M. V1 is actually the ml of EDTA into M, which is molarity of EDTA, into 100 into 1000 upon capital V, which is the volume of water sample taken. For finding hardness of water, this is the formula. So just let's put the values into the formula and we get 370 ppm of CaCO3 equivalent as the hardness of water. So when we put values in this formula, we get hardness in ppm of CaCO3 equivalent. So this is the total hardness. After boiling, once you boil the water and filter it, we know temporary hardness would be removed. So these details which are given of water sample and how much EDTA is required, if we put these details into the formula for calculating hardness of water, we are going to get permanent hardness, because after boiling and filtration, temporary hardness gets removed, permanent hardness remains in water. So for calculating permanent hardness, we will put V2, that is then after boiling how much EDTA is required, into M, molarity of EDTA. We are using the same EDTA solution, so molarity would be same, into 100 into 1000 upon V, that is the volume of water sample taken. So second time also the volume of water sample taken was 100. So let's just put the values into the formula and we get permanent hardness, which is 214 ppm of calcium carbonate equivalent. But in question, if you have a look, they have asked us for temporary and permanent hardness. So we have total hardness, we have permanent hardness, and now we need temporary hardness. So we know that total hardness is equal to sum of temporary hardness plus permanent hardness. So we have total hardness, we have permanent hardness, we need to find temporary hardness. So temporary hardness would be total hardness minus permanent hardness. So if you do it, the answer is 156 ppm of calcium carbonate equivalent, which is your temporary hardness. So in this question, mainly you need to remember that if the water sample which is taken, if it is untreated, we have just taken a water sample and titrated it with EDTA, then in that case you are going to get total hardness. While if the water sample is boiled and filtered, then the values which you get, if you put it into formula, the hardness which you are going to get is the permanent hardness. Because once you boil and filter a water sample, temporary hardness gets removed and permanent hardness remains in water. Okay, so this is how we solve the numerical. Here are a few practice questions which you can try yourself based on the same formula. So this is the formulas which is given. This question which you can see, fourth one, for this you have to use this formula. So we have solved this numerical, such kind of numerical in our previous video session. So you can go and check it for during introduction of hardness of water. And the second and third, for second and third, you have to use the formula for determining hardness of water by EDTA method, which we have just seen. Okay, that's all for today. Thank you, everyone.